Well, it will be funny today. As you can see, KiCad has some serious problem on my machine right now. Probably I should restart my machine, but the live stream is running and I don't know how to resume it after restart. So I found that when the main KiCad window, the first window with the project files and the application bar, if it's on my main monitor, the screen doesn't blink, or the windows are not swapped in a fast way between each other. But I can't run both PCB editor and the schematic editor at the same time. Otherwise, there is this effect. So yeah, it will work, but it will be funny today. And I hope I won't accidentally close the browser window, because when the windows of KiCad are switching between each other in a rapid way, I have to use the hotkey to close the window. And when the browser window is active at the time I'm pressing the shortcut, I can accidentally close the browser. So it means this session will be much different. But anyway, we have to improvise. We have to be like authentic, right? So what are we going to do today? I realized after the last week's session that there is something missing in the schematic, and what's missing is not crucial, but it's essential for smooth and comfortable debugging and testing the board. And this is at least one LED on the output. And I believe I will monitor with a few LEDs all the outputs. And probably, yes, all the outputs. And I think a few test points are missing as well. For instance, near the threshold output, output of the trimmer, input of the IC. I will monitor the heartbeat signal, the output signal, and the wake up. I think it's a wake up. Let me refresh. Let me refresh my mind. Okay, it seems that the issue is not in my... Okay, anyway. Yeah. I wanted to say that I'm going to open the datasheet of the IC, and then I will check the wake up output, or what is. I'm sorry, I forgot already what each output means. So WU, let me open it in the browser. Okay, here is the data sheet. Here are the pin diagram of the IC, and here are the pins. So wake up request is input. So it will be input from the host controller, but as I can see now, the device is completely like independent to any control logic. It means I can use a button to wake up the device. I can use the, I can, it can be completely standalone without any host controller. That's good. So I think I am going to redesign the schematic a little to enable this kind of control. So threshold will have, let's make the changes. Okay. The fun fact is that I have been working on a new design in KiCad since this morning for about 5 hours. After I switched off or closed the KiCad and opened it for this project, it started doing strange things. Probably it's connected with sharing the screen. I don't know. Anyway, I was looking for the test point. I think 2mm test point is okay, or enough for our purposes. So threshold will have test point, wake up is input, output is output, and heartbeat is output as well. Yes, heartbeat is output, so there will be LED, and output is just output. So what are parameters of the HB and outputs? Let's find in the data sheet. So heartbeat. So let's find heartbeat. Heartbeat output. Okay, this is the output section. Digital output, low, not detected, high, detected. So we can use the NMOS switch with the LED in the drain, and this will be the easiest way how to monitor the output pin state. I don't know what the output is capable of, what current can be synced from this pin. If the syncing capability or sourcing capability is enough, the LED can be sourced directly from the out pin, but I have to verify. So there should be some electrical characteristics. The datasheet is not optimal, but we will find it. Electrical specification. I open characteristics. Probably it should be applicable to all ports. so both input and output. So the output high drive strength is 6 milliamp, and the low state output drive strength is 10 milliamp. Okay, so the LED can be driven directly from the output, and I think I will use this strategy. The typical LED that I'm using in 0805 package size, when driven with the current of 1 milliamp, it lights like crazy. So this will be definitely enough, and the output pin will not be like overloaded with this current. So heartbeat and output will be monitored by the LED, connected or sourced directly from this port. That's the change number 1. So let me I'm missing the window with the here's the symbol editor. I don't know what when any other window is on the monitor that I'm sharing the screen of, the window starts blinking. I don't know why. It's annoying. So the green LED will be I find out that this today's session is really special. I didn't. Now it works. Okay. So 1K will be the resistor for the LED. It means that when the power supply, when the IC is supplied from 3.3 and the forward voltage of the LED is above 2 volts, the current will be just about 1 milliamp. It can be 1K5, but I will use 1K. Okay, and here will be ground. So this is the combination for the output. The same will be used for heartbeat. I think the heartbeat is the output signal as well. Yeah, it is. And this electrical characteristics table doesn't distinguish between the ports, so this is output. Okay. Yeah. The worst thing that can happen is that I will have to unsolder the resistor to disconnect the LED from the output. So very easy to do. Okay, so these 2 ports are monitored now. What did we say? That we want to assert the wake up to the active level, which is, let me check, the wake up request. Okay, there is no, probably the high level is the active level, but let's verify. Wake up request, sleep period, wake up request. I'm looking for some waveform or some diagram depicting the wake up edge and the heartbeat signal or the output signal. Liquid detected. Okay, this is just the output. Heartbeat. Okay, it's the asynchronous output, like periodic output with some period of, I don't know, yeah, sleep period plus 100 millisecond. Heartbeat output, yes. To microcontroller, sure. The host must use a signal on the wake up pin to trigger acquisitions. Okay. And when the wake up is not with the negation, with the overhead line, it means that the active level, the high level is active. So we will use, where is my KiCad? Here. We will use the button, connected or not connected, switching the 3.3 voltage like this. No, I need some space for the net. Here will be the net. I will use 10K. It means we can use 100 nanofarad because the time constant will be about 1 millisecond. No, 1 millisecond. 0.1 millisecond. No, 100 times 10K times 10 to minus 9 is minus 7, 10 milliseconds, I think. Okay, this will work. Wake up. And we need a ESD diode for sure here, because I will touch the I was so clever that instead of duplicating, I just moved the switch from the reset. So okay, and as I said, we need a diode, the ESD diode, protecting the port. Like this. And for the reset port as well. Because wherever human touches the PCB or any component, the discharge event can happen. And we don't want to discharge charge from our bodies into the IC. So this can be the wake up. So it means the inactive value is a low level. When we switch on the button, when we press the button, the level goes to 3.3 through some RC circuit and asserting the wake up input signal. I think it can work. Jumper, 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 jumper. Okay, this is the sleeper period or sleep period. Okay, so 2 diodes and the wake up input. Let me check how it works. The host must use a signal on the wake up pin to trigger acquisitions. So it seems that the wake up is like asynchronous input, able to shorten the sleep period. I don't know. I don't know. This is why I want to test this device. Here's. Additionally, the 𝗞𝗶𝗍𝗱 provides on-demand wake-up via the wake-up pin. The wake-up pin detects falling edge signals. Interrupts the sleep state, checks for liquid presence, and returns to the sleep state. Detects falling edge signals. So it means that the active level is a low level. But why the wake up label, the name of the pin is not negated? Detects falling edge signals. Yeah. Okay, let's search through the entire data sheet for the WU. Falling edge signals. Okay. There is only serial registers, to host controller, nothing special. The host must use signal. Okay, and we are going in the circle. So it means that falling edge signals. Okay, so I have to change the schematic because it detects the falling edge signals. So yeah, frankly, I believe more in the missing negation mark, like the overhead line on the wake up. How this circuit works. When I press the button, the wake up goes up, and when I release the button, the signal goes again to the low level. And this can be our falling edge event. Detects falling edge signals. Okay. It means that I should, do you know what? I will do this. This circuit can generate the falling edge events as well as the rising edge levels. We will see. And if there is something really wrong, I will place the 0 ohm resistor between the button circuit and the input pin. Yeah, 0 ohm is a fine value, but I need 0.6, 0.3. Okay. So I think it's bulletproof now. We can disconnect the button circuit. It's ESD protected. We have monitored out pin, heartbeat output pin, and we can generate negative or falling edge events, plus as well when the button is released, we can generate the rising events as well. So the reset port is ESD protected as well. We don't need to protect this. And I think even those 4 signals or nets are not to be ESD protected, but because the level is, I think, detected during the startup. So yeah, these ports are already protected, but near the connector. Okay. Yeah, I'm checking the comments. Yeah, no comment yet. Frankly, this session is so special that even though the StreamYard tells me that I'm streaming, I'm not sure. I'm not sure about that. Yeah, let's continue with the schematic. So as we agreed, or as I said, the schematic is ready to be implemented. So annotation, don't blink, don't blink, don't blink. No. Yeah, I had to close the window because for obvious reasons. I have to keep the annotate schematic window on the main window. I'm really sorry for that, but this is how it works. I'm checking the ERC. There is no issue, but now, now I'm thinking about how I update the PCB from the schematic when only one window can be open at a time. I think I can update the PCB even when the schematic editor window is closed. Let's check. I will save. I'm saving the schematic editor window, closing it, opening the PCB editor. Okay. And now I am hitting the F8 for our tools, update PCB from schematic. I'm doomed. I am doomed because I don't know how to do it. Ah, doesn't blink. Ah, oh, PCB is updated. Unbelievable. It's like, I don't know how to describe this situation. It's an unreal situation. Never mind. Wake up. This is the button. These are 2 LEDs. This is the ESD diode. This is the isolating 0 ohm resistor for the wake up. Here is the 10K for the wake up. Here is the heartbeat resistor for the LED, and here is the output resistor for the LED. Okay. And here is the threshold test point. Can be placed here, for instance, near the trimmer. I am going to move the reset button to a different location, like here. Yeah, the issue is that I wanted to keep this area at least. Yeah, okay, that's okay, that's okay, that's okay. Can be placed here. Here is the second button to be placed 10 millimeters far from the reset button. Oh, it seems that the windows stopped blinking. I'm going to check it. I don't know what happens. It doesn't work. Seems that it works. Yeah, and I have opened. Okay, both windows are open at the same time. Okay, that works. That's good. Anyway, I wanted to place the wake up button 10 millimeters far from the reset button. Okay, I want to place the we want to place the ESD diode for the reset, for instance here. The same ESD diode for the wake up button, close to each other, like this. Okay. Then we have pull-up resistor for the wake up. Can be placed here, or to have somehow symmetrical schematic can be placed here because 3.3 line is here. We have the capacitor for the wake up signal. We have the isolating 0 ohm resistor. Where is the wake up signal? Wake up signal is here. So I think it can be placed here. I can't see any reason why we don't place it there. And now we want to monitor both heartbeat and output signals. Below the reset or below the wake up button, there is plenty of space. So I think I will place there the LEDs. What's this again? Yes, this is the UART enable jumper. I don't like the position of it. How it looks in 3D. Yeah. Okay. It's just a board, right? So heartbeat can be placed here. The other LED can be placed here, in between the, or next to each other. I don't know. Or like this. When thinking about placing the future labels for these LEDs, I think I will place them close to each other, and the labels will be on sides of the LEDs. I think that will work the best way. Okay. Okay, junk to review. There's always junk. Okay, these signals can be routed on the bottom layer. That can be easy to do. Okay, so let's work on the layout. So we can start with the button, a similar way as before. I will place these two vias connected to only one layer. The reason is to provide the PCB with some firmness to be like resistant to damage on the buttons. There is no risk of damage because the button is a really low profile one, and I'm not going to express any force when pressing the button. But yeah, I think it's a good habit, and I don't want to avoid it when routing my boards. So why not? Now what? I will need to route the bottom layer . Yes, the bottom layer tracks. So I will route it like this on the top layer, and it means there is the full width of this area that can be dedicated to these two signals. Yeah, I'm placing the ground vias next to each other to be in line, because this way provides me with some cleanliness, and I want my boards are clean and neat. So now we can switch to the bottom layer and route these two signals. Okay. Looks pretty good. Now the wake up for the button. Okay, here are the ESD protecting diodes. Yeah, and when speaking of symmetrical layout, you can use this. Ideally, you shouldn't do this. Then I don't know why I'm doing it this way, routing this way in this way, when I want to say that ideally you shouldn't do that. Ideally, there should be via close to the ground pad, because the charge, if you imagine the charge going through in the space between this track and the bottom layer reference plane, the energy goes through the diode and here in between the top and bottom layer. in the space of the PCB. And ideally, the via should be here to shorten the distance, the distance where the energy should travel or must travel. But I like the symmetrical design, and the fact that these two lines are firmly connected to the ground. I will do this way. Yes, and here is our line that I previously deleted. I'm not sure, but yeah, I did. No comments. I don't know if he's streaming. If not, then the next week will be another chance. But I will not repeat these actions. So if you are streaming, you are lucky, you can watch. If not, you will miss this part. But it's not so important anyway. And the wake up. So I will no, come on. I will place the via here and connect the third bottom layer track for the wake up. Exactly like this. Yes. Looks good. Looks good. And this is to be connected as well. The test point for the threshold. Now. And silk screen. If you remember, in the place somewhere here was my logo and the name of the PCB. This way, we have to make some changes, because obviously we don't have space for them, for the new, the new components take spots on the PCB that was previously taken by the labels. I think when I'm grabbing this, oh, it's not visible now. A reference field. I think in the previous version of KiCad it was called differently. I don't know how. Label? The reference label? Reference field or only reference? I think the field is a new word here. If you remember, please comment in the, please drop a comment on YouTube video probably, or on LinkedIn. Yeah, I don't know. I'm not sure, but it seems new to me. So here must be our labels. Reset. Here is wake up. Wake up. Capitals. Wake up. Wake up. We don't need the reference designators for the LEDs. Nor for the resistors for the LEDs, and we need labels for LEDs. I will use the 𝗞𝗶𝗖, and we have heartbeat. It's a long word, long label, long name, so I will use the heartbeat only. And unfortunately, this can be placed here, acting like an arrow, as I like it. Yes, that's exactly what I wanted. So this is heartbeat, and this one you can duplicate or copy paste the label created by 𝗞𝗶𝗖𝗱, but you have to call the 𝗞𝗶𝗖𝗱 plugin again, not the property window. So when selected the copied label made in 𝗞𝗶𝗖𝗱, you have to call again the 𝗞𝗶𝗖𝗱 plugin, and this is output. Yes, output. Yeah. Yeah, I think this is better. Here is the cat, which tail is cut by the button. No problem. And here is our board name. Where to place it? Where do you want to place it? Tell me in the comments. Right now, there are no comments during this session. It's strange. Anyway. Threshold. We can place it here, below the jumpers. Yeah, that can work. What do you think? Why I'm asking you if there are no watchers, but maybe. Maybe I will be surprised when I am checking the numbers when the stream is concluded, because LinkedIn shows me the analytics for the stream. Usually there are like 20 peak watchers after 10 minutes of the show, like 10 minutes in the show, and we are 47 minutes in the show, so probably there is really nobody here. But yeah, you can drop a comment. Make me happy. Drop a comment, please. I want to be sure that the stream is coming. Not coming, going. Stream is running, not coming. Threshold. Yeah, I'm fighting with this fact. The threshold label is below the trimmer. That's good. And we have the test point here. So I can do two things. I can remove the test point near the threshold label, like below, or I can add another label with the threshold, but there will be two threshold labels, which is really stupid. So what should I do? Or I can do this, to place the threshold on the side of the trimmer, like here, and put it here. Why not? Not bad. What do you think? How it looks in the 3D? Let's check. It looks good. I think it looks good. There is an issue. I want these labels, these two labels, to be readable when I bend my head to the direction of my left shoulder, and now it's the opposite side. So I have to rotate the labels and change their properties. So left cap will be the bracket, and the right will be bracket as well, but the sharp one. This and yes, exactly, much better. Yeah, it doesn't matter, but yeah, I always place the labels to be readable when you bend your head in the direction of your left shoulder. I don't know how to describe in English, but I hope you understand. Wake up reset. The question is, why not to use labels using 𝗶𝗶𝗃 as well? But threshold, yeah, I can. What do you think? This threshold can be used the same way as the LED labels. So working like an arrow, perfect. Wake up. Yeah. Do you know why I'm typing the text instead of copying? Because the 𝗶𝗶𝗃 home first command. I see there are RX and TX lines. You make hi 𝗜𝗁𝗁𝗃 𝗶𝗶𝗃. You are making me happy because you are the first commenting user right now. So it means that the stream is running. Thank you. Is there? I see there are RX and TX lines. Do these two lines have to be the same length? No, no. This is the very low speed UART signal, so you don't have to bother with the length tuning. Yeah, the rule of thumb is that let's say you have to take care about the length tuning for the signals of the maximal frequency of 100 megahertz and up. And this a few kilohertz UART signal is not something like this. Anyway, thank you for the question, and thank you for the verification that the stream is running. You made me happy. Thank you. Yeah, and I was saying that I can't use the copy paste inside of the 𝗶𝗶𝗃 plugin because 𝗶𝗶𝗃, I don't know why, don't support copying into the inside of the editing dialog like here. So I don't like this. These three labels are too close to the board edge because there is some constraint that the label mustn't be so close. I think 1 millimeter or 1.5 millimeter for the Ē𝗓𝗓 manufacturing, and I don't want to have the cutted labels. So this is definitely better. So the conductive and capacitive. Okay. Okay. So let me check how to place the labels, how to place the jumpers. We have to place some hint on the PCB of how these jumpers should be placed. At least a simple helper like this. So this is, I think, quite clear, and these jumpers are clear as well, including this one. Okay, it's time to ERC, or DRC, pardon, DRC. DRC is here. DRC is here, and let's call it, no blinking. Yes, thermal zone incomplete for this one. Okay. There are two options. You can change the board setup to allowing one spoke only, or to change the pad connection to solid, as I'm going now. Perfect. So only the overlapping courtyards here. I explained last time that I placed there, I placed these two jumpers close to each other to be able to use either two short headers of 2 pins in one line, 2 pins, or 2 times 2. So it's by intention. And the myriad of warnings is about our segments. Yes, we are connected on one track only. Yeah, like here. I explained why I do that and why this is not an issue. Overlapping silk screen, no problem. As well. And a myriad of warnings for the unconnected ends of the tracks, but this is our sensing segment, so we need it. So it seems that our PCB is fine. And yes, I don't like this. I don't like this. I have to change it to, or I want to change it to solid connection for the entire IC. Yes. Much better. Yeah. Looks good. And looks good as well. We have another comment. Hi, 𝗞𝗶𝗖𝗱 𝗵𝗁𝗀𝗻. Is there a way to make a full analog capacitive touch slider with a simple analog components? I don't know. My piece of advice is, my 5 cents here is, go to Microchip, or yeah, I recommend Microchip because they create the low expensive, reliable touch controllers. Look for, I think I have one in my database, so please give me a sec. Here is my library, touch. Yeah, this is the 5-key option, 3-key option, or Azotec as well, 1 channel capacitive. Yeah, so this is the single key by the, yes, this single key by the Microchip. Yeah, this is the best one, I think, because it's without any logic, or like control logic communication. It can work like touch sensor or proximity sensor. It's extremely simple, extremely low expensive, and extremely easy to use. So if I were you, I would use this. if there is some task to make it completely using analog components, I can't help you. But is this component the analog component or not? This is the digital burst mode charge transfer sensor. Okay, but there is no clock, there is no communication, there is no, as you can see, there is just sync or mode input, but it can be the static signal. So yeah. No problem. I am happy that you like my answer. If not, try to look for the for another component or other components. So again, I recommend microchip 𝗫𝗁𝗃42�QT1010 or similar components of the same family. So I can see that we can conclude the session. Let me check. Let me check again the board. It looks good. There are no big issues, or I think there are not issues. We improved the PCB significantly by adding 2 LEDs, by adding wake up button, by adding the threshold test point, by, yeah, I think by making the PCB better. So thank you for watching. Thank you for being here. Thank you, 2 gentlemen, for their comments, because I am now 100% sure the stream is or was running. Thank you. See you next week. I will be designing something new, probably some sensor or some power supply board or some charger. I don't know. If you have some idea, feel free to send me a message on LinkedIn or comment on YouTube, whenever and wherever you want. So thank you again and have a nice rest of the Thursday. Bye.